Ever pondered on why understanding the difference between discriminatory and generative methods in statistics is crucial? Well, it's like appreciating the subtle variations in the ingredients of two similar-looking dishes. Both might appear the same, but the taste, texture, and the overall culinary experience are distinct. In the world of statistics, discriminatory and generative methods are two such ingredients. They share some similarities, but under the hood, they are fundamentally different in application. Discriminative methods are like seasoned detectives. They directly learn the hard boundaries between different categories of data. They're concerned with the question, given this data, how can I categorize it? For instance, in a medical study, a discriminative model might be used to directly predict whether a patient has a disease or not based on their symptoms. On the other hand, generative methods are like storytellers. They learn how the data is generated in order to categorize it. They ask the question, if I were to generate this data, what steps would I take? For instance, in the same medical study, a generative model might predict whether a patient has a disease or not by understanding how the symptoms are related to the disease and to each other. Now, imagine you are working on a study to predict the occurrence of a rare disease. A discriminative model might struggle here due to the lack of examples of the disease, but a generative model, understanding the underlying structure of the data, might still be able to make accurate predictions. However, it's not always sunshine and rainbows for generative models. Consider a scenario where you have a wealth of data, but it's messy and interconnected in complex ways. Here, a discriminative model might be your best bet. It can cut through the noise and find the most direct path to the answer. In essence, the key difference in application between discriminative and generative methods lies in their approach to the data. Discriminative methods directly predict the output from the input data, making them efficient and straightforward in scenarios with ample and clean data. Generative methods, however, model the underlying structure of the data, making them more flexible and capable of handling more complex and limited data scenarios. So, the next time you dive into a statistical problem, remember this. Discriminative methods are your direct, efficient detectives, while generative methods are your flexible, insightful storytellers. Like chefs choosing the right ingredient for their dish, picking the right statistical method can make all the difference in your data analysis.